All right, so today is lesson 3.7.3, and what we're going to do is I'm going to show you as much as I can of day 3 and day 4, and you can listen to it and stop at any time, and I'll tell you when to pause. But the first thing we do is we look at our inequality that's sitting right here. Remember we talked about if there's anything on the outside that we have to get rid of it first? Well, this one has nothing on the outside. So what I'm going to do is I'm just going to split it up. And don't forget, 2 things that we talked about yesterday before I left was that this sign right here is a greater than, and that's an or, meaning an out. Don't forget then if you have a less than, that's an and. Okay, so on all your lessons, I'm going to be putting or or and by them once I've made a decision not to move anything. So I didn't move anything, so this is going to turn into an or. So I write 4a is greater than or equal to 32. Or I write 4a, I switch my sign over, and I put my negative 32. Remember, this is an or. And with absolute value, everything has 2 solutions. It has one on the positive side and one on the negative side. So now I'm just going to divide by 4. And what I get is a is greater than or equal to 8. Then I go over here and I do the exact same work. And I get a is less than or equal to negative 8. So when I go up here, remember this is an or, so I would never choose this one, and I wouldn't choose empty set, meaning no solution. I wouldn't have 1, but some people might say that, so I'm going to pick, and look what I have here. Even though I wrote it the other way around, this is the exact same thing, it just depends on what work you did first. Okay, so that's question number 1. So now that I did that, I'm going to actually slide this answer up there, out of the way so I can get the next part of my work in. So I'm going to switch colors on this one. And this is telling me, and you know what, I better move this part over here just a little bit more so you guys can see. And hopefully you're stopping and pausing anytime you need to. When we talked about it, notice it says right here, solution or solutions. Well, because of this absolute value, you're more than likely going to have 2. But what happens is right here, you have something on the outside. So you have to move that first. So since I see minus 4, I'm just going to add 4. And what that creates is this inequality. And it's super, super easy. Because now all I do is say, hey, this is an equation, so I'm going to have one solution at 8, and then I can rewrite this and say the other solution will be at negative 8. So if you look, never would I choose F. I wouldn't have, if you look at it, I will have 2 solutions, and I think it's getting covered up, so I'm just going to erase this a little bit, and there they are. I can be at n is negative 8 or 18 and positive 18, so I'm going to choose that one. Okay, and if you take a look at this one, this is 10 and 18. That doesn't make sense, but it does make sense if somebody didn't move the 4 first. Remember, we always have to move the 4 first. Okay, so the next one that I'm going to do is I'm going to go down and I'm going to look, and I have 2 things to get rid of. But remember, this one's an equation again. So what I'm going to do is I'm going to subtract the 1. And then I get this. Because again, remember, these are all outside things that I have to move. And I always do the adding or subtracting first. We talked about that yesterday. So now what I'm going to do is I'm going to turn around and move the 4. But remember, the 4 is connected by multiplication, so I'm going to divide. Okay, and automatically what happens here is I get this 2x, and I get this answer of negative 1. And we talked about it yesterday and the day before. Once you've moved everything, you cannot get an answer of negative 1. You cannot. This is a no solution. And remember what it looks like? You can always choose that one that means no solution. Okay, now if you look down, there's a little tiny bit farther down, and I have to see if I can move this up a little bit. Okay, right here. Come on, your screen. See if I can move just a little bit more. All right, what is different about problems 2 and 3? And I've already kind of said that, but hopefully it triggered in your brain. 2 and 3 were actually equations, not inequalities. So they were equations. Okay, so I'm going to go on to the next page. And what we want to talk about over and over and over and over and over again, okay, is what's called sandwich. And then what's called or. Remember, sandwiches are always the ands, and they are always the less thans. The ors are the greater thans. And you remember, that's what happens right there. They turn and they go out. Now, these are just writing, so they're not really that big, but what we're going to do is we're going to talk about the fact that it always is going to tell you from somewhere, okay, from somewhere. So in the first example, all real numbers x, okay, And what they have to come from is 0. So where we go is we come from 0. And then you just have to say less than 2 units away. Okay? And you just have to learn how to write them. You don't have to solve them. You just have to write them. This one says all real numbers x that are more than 5 units, 0.5 units away from 4.5. So we say, and we always use minus right here in the middle, you guys, we always use minus. And it says more than, so I'm going to put a more than 0.5 units away. This one, all real numbers. And it says that are how many units away? Well, they're negative 4 units away. Ooh, guess what? And then less than 1 unit. So what happened to this minus? Minus, it turned into a plus. So the key here is that all real numbers turn into x. This middle sign all the time is subtract, unless it turns to a minus. This sign just drops down like it is. And then we just talk about how many units is away. So it says from negative 4, from 4.5, from 0. And then on the outside it goes from there. So here's the next part. So let me get to the next page. And these are super easy. And like I said, I'm pretty sure that I'm going to put both days together. So kind of hang with me. And when I say pause, you can pause until tomorrow if you want. So an ideal diameter of an aircraft tire. Now that's pretty big because we're talking about an airplane. The ideal diameter is 105 inches. The acceptable air for the air in the tire is 0.15 or 175 inches. It says find the range of an acceptable diameter. So the first thing I'm going to do is I'm going to go D for diameter, and I'm going to find acceptable. And it says it has to be 105. So guess what? Here's the 105. And then acceptable, and by the way, this is going to be a sandwich because we need it to be sandwiched between 105 something and 105 something. So we're always going to use a less than. And in this case, it's going to be equal to because we can equal this. If you want to say acceptable air, so somebody could air up the tire a little bit more or a little bit less. And so I'm going to put the 0.175 right there. And because this is a sandwich, what I'm going to do is now sandwich it. This is my inequality, and now I'm going to start solving it. So if you go ahead and now this is your work, I think what I'm going to have to do is slide this part down again a little bit. This is your work. So you can see I'm just going to add 105. And notice what I'm doing because what's going to happen is that's 105.175 because it's very small. On the other side, I'm going to take 105 and take off 175. And if you look at what I'm doing and subtracting off, that means it's 0.825, 104, because I took 1.175 off. So my acceptable range is 104.825 diameter. Let me get rid of a little bit of this because you can't see it very well. For the diameter all the way up to 105.175. That's acceptable on the gauge. So if they were measuring the tire, that would be acceptable. Excuse me. So now what we're going to do is we're going to do the next example. We're going to do the tractor. So I know this is kind of hard, but you can pause and you can do it anytime and you can redo these notes at any time. So it's going to be hard because I'm going to slide this back up and erase. I'm sorry about that, guys. You can, like I said, pause beforehand if you have to. So a tractor crankshaft, and I don't know if you know what the crankshaft is, but that's the part that actually makes the motor go. And notice what it says. It's designed to have a radius of this. This is what's acceptable. So as we start off, I'm just going to use R for radius. And that's where it says it's acceptable. That's what you have to do. But look at you guys right here. It cannot be off by more than 0.005. Very, very small amount. Oh, can you see I already started to rewrite it? So here's my R minus the 4.25. And here's my and because it's my sandwich. And I can be above by 0.05 or below by 0.05. And that's why you can see it's a sandwich. So then I go ahead and I add 4.25 to both sides. Look what I'm doing. I'm lining up my decimals so you can see that. Or I can take off, right? So on this, for this case, I need kind of a little bit more room. I guess I'll have to go over here. The acceptable on the top is 4.255 for a radius. And on the bottom, look what we take off. We take off. So if we take off 0.05, look what we're at, 245. So we're 4.245. and that 4.255. And I think you can see a pattern coming here. This is 245 and this is 255. So that's only, if you think about it, a tenth away, well, 100 tenths, hundreds, thousands, that's 1,000th away in a mathematical part. Okay, now let's see what else we have. I think we have to go to the next page to get the next one. So let me set this down. Okay, ideal weight for an exercise ball. So think about that. We're trying to get all kinds of real life situations for you, but the ball has to be 175 ounces if you want to say weight. So here's what's acceptable, and maybe I should have used W for weight, so I'll change that. The weight can be 175. Some of you are asking why we always have to have minus here. Remember, we're going to undo it with adding. And we're going to sandwich it, so we are going to use less than, and this time it's 0.35. Okay, so there's our inequality, but now we want to find our range. So we go W minus 175, and then we go to the other side and put minus 0.35. And so you can see how easy it is to add 175 here, so we're going to be at 175.35. And when I go down on this side, I have to take 175 and take off that and subtract. So if you take off, you don't get 175 anymore, you get 165.65. And I think you're kind of getting maybe this concept of how, how much space is in between, because this is 35.35 down and this is 0.35 up. So right there, I'm going to stop. As far as explaining things, but I'm going to keep going in the notes and put the notes together. So you can pause and then come back for here tomorrow. And so I will tell you it's about 11:50 on the time. And then I'm going to pick up about at 12 minutes. Okay, so here's my 12-minute mark. And again, what we're doing is we're reviewing everything, and then it does say to graph and check these, and then we're going through those word problem ones. And I put together a packet so that you had 2 days worth of stuff to do. Notice this one is an equation. Okay, so anything on the outside we get rid of first, so I'm just going to add 5. And so what I have is this. Okay, and since it's an equation, this is super easy. We drop off the absolute value and just write 3 and -3. And it says to graph it, so your graph would look super easy. It'd just be 2 little dots on a number line. And the next one, there's nothing on the outside like there, so we just write 3x minus 1 equals 8 on this side and -8 on this side. And then we just go ahead and add 1 to 8 to get 9. And then we'd add 1, and this is the weird part because you're going to get -7. Okay, and I have to scroll this up a little bit. So actually, I can just write it over here. So I have -7, 3x in the middle of 9, and you can see I'm going to be dividing by 3. So big deal. I get this -7/3 here, and I get 3 here. So if we're going to graph it, here's 3, super easy. Okay, and for those people that are having trouble, this is 2.3 repeating. So I would just go like, here's -2, and here's -3. I just put it maybe right there. Okay, on a number line. And you're going to have multiple choice anyways, so it's kind of nice to know that. Okay, so what's next? All right. So this one is one that almost everything is done for you, but it says starting at 100 feet away, your friend skates towards you and then passes you by. She skates at a constant speed of 20 feet per second. You can see they put it right here already. What time, and it says after t seconds, okay? So what time is she 40 feet away from you? And notice what d is, her distance d. So it's like, wait a minute, when is she 40 from you? Well, think about it. If I put 40 right here, okay, and I solve that. Now, one thing you got to be careful of, it's not going to just be 40 because you have this absolute value. It's also going to be -40, okay? And so what I'm going to do is I think I'm going to pause, and I'm going to make another video for the rest of this. So I'm going to pause because I think I'm going to run out of time in just a second.